Before the workshop starts, we're going to show you how to navigate through the video. Below the YouTube video is the Show More button. Click the Show More button to reveal the index. You can skip to the point that you want in the video by clicking the blue time link.
Where we left off then was we're finished looking at single variable data, and now we're going to look at bivariate or two variables of data. Now I'm going to give you out a T&L for this workshop. It's on the correlation coefficient, and we'll be looking at different aspects of that T&L over the next half hour, okay? So you have it in front of you there. We're going to kick off though back with our census at school, and we're going to look at more information on heights and arm spans. Okay, now this is a relationship. So we are posing the question, is there a relationship between a person's arm span and a person's height? And we want to see, is there enough evidence there to say that there's a relationship, okay, between those two variables. So what we're going to do is we're going to look at it on the scatter plot. So that is how we are going to put this on a graph. It's very similar to the XY axis, isn't it? Okay, so we put it on a scatter plot. So I'm going to use my GeoGebra here. This is on the student CD, what I'm going to use here with you. Okay. So there's all of my points, and on this axis, on the horizontal axis, we have arm span, and it's been plotted against, on the vertical axis, the height. Okay. Now, this is a scatter plot, but they can be hard to interpret, okay? So a really nice teaching methodology is to give like a frame of reference. And a really good frame of reference is to get the kids to plot the average arm span against the average height, okay? The mean of, say, the x's against the mean of the y's. And that's like a really good starting point for discussing what's going on all around it. So this isn't something that they have to do in an exam. It's not anything like that. It's a teaching methodology, but you'll see that it's really, really helpful in helping them negotiate what's happening here. So I'm going to put that in straight away. Can you see it come in there? The little blue dot. So describe this person to me. I know they're an imaginary person at the minute. Describe them to me. This person has got? Perfect. And yeah, arm span of about 160, which is the average, and about the same. So this person here that we're after putting in is a person of average arm span and average height. Okay. Now what we can do is we can use that point to split up the field. So if I draw a line down through that point, could you describe for me the people that are on the right-hand side here? Perfect. All of these people have above average arm span. Okay. Now, I guess we don't know yet if they all have above average height. So what we'll have to do is we'll have to put in another line across. So if we click into this one then, it'll divide up my field again. So you can see here, this person and this person, they're above average arm span, but they're actually below average height. So the only people that are above average arm span and above average height are these people here. And what this lets you do is, when you click in, it'll colour them for you to make them easier to talk about with the kids. Okay, so you see the blue people here. Describe them for me. Yeah, they have below average height, below average arm span. So it's a lovely frame of reference, isn't it? Okay, now I'm going to take those off for a minute, those lines, and I'm going to ask you then for the correlation. Okay, so the correlation here, we know for an ordinary level student, they just have to be able to look at this and to say if there is strong correlation, if it's positive, if there's weak correlation, if it's negative. That's how they have to talk, isn't it? They don't need to get the correlation coefficient. So let's have a little talk about the correlation then. We'll forget that the correlation, we know it's between -1 and 1, isn't that right? No problem. Okay, but leaving that aside, okay, the kids just have to, at ordinary level, have to describe this correlation. So would you say it was a positive correlation or negative correlation? Positive. And why do you say it's positive? They both increase together, absolutely. So as your arm span is increasing, it looks like the height of the person is increasing. Very good. So that looks like it's a positive correlation. Okay. Would you say it looks like there's a strong correlation between arm span and height, or a weak one? A strong correlation, yeah. This looks like a strong correlation. Now, if you look at your T&L, I know this can get tricky. So just have a wee look at the T&L there on page, let me see, find it now for you. On page 6. So this idea of the kids saying whether something is strong or something is weak, it can be pretty hard, can't it? Say, well, what exactly makes it strong? What exactly makes it weak? So can you see here, we have a note in the teaching and learning plan. There is no universally accepted criterion for applying the adjectives strong, moderate, or weak to correlation. Okay. But the State Examinations Commission, the report on the trialling of the Leaving Cert in 2010, you remember the trialling report that we did in Workshop 3? Well, they said in that a good guide is that if the range of values of the correlation coefficient are between 1 and -1, that if your correlation coefficient is less than 1 and greater than 0.6, that you can say it's strong. It's just like a reference point. As it says there, there's no universally accepted criteria, but just for yourself, okay? So we know it's this. 1 means a positive correlation. Here is negative correlation. So if it's less than 1, but it's greater than 0.6, they're saying that it's positive and it's strong. Okay. And then if it's between 0 and less than 0.6, they're saying that's a good enough guide for saying that there's a weak correlation. Okay? So if R is less than 0.6 and bigger than 0, it's got a weak positive correlation. Okay? And then the negative ones, if it's a negative correlation, so that would mean that the arm span, as it's increasing, it looks like the height is decreasing. If it was a negative correlation, the same thing is true then. So if or is greater or equal to 1 and less than or equal to minus 0.6 and minus 1, that's going to be a negative correlation and it's strong. Okay. And the same then is true if it's greater than minus 0.6 and less than 0, we say it's a weak negative. Okay. I think they're very helpful, aren't they, for answering those questions for your ordinary level leaving certs. Now, I know that they will never look at the correlation coefficient. This is really just for us, isn't it? And especially if you're making questions for them, you can look at the correlation coefficient, can't you? And you can make questions where you know, well, I'm happy to stand by this, that this is a strong one, and I can teach them how that looks in the classroom. Okay, so what's nice about this is they really need to get this into their head, the kind of what's positive, weak, negative, strong. So what's nice here is we're able to move around the dots. Okay, so if you look here, I'll show you, if we click on the correlation coefficient, at this moment in time, we thought that this looked like it was positive and it was quite strong. So the correlation coefficient should definitely be bigger than 0.6. So let's have a look what it is. So we can see it's 0.8. Okay. But we might want the kids to understand, well, what would a weak positive correlation look like? We can move these points around. Can you see that? If you start spreading them out, that we don't have such a nice correlation going on there. Can you see now we're into a weak positive? It's much more spread out, isn't it? My correlation coefficient's gone down to 0.54, much more spread out. And if we put back on our quadrants, we can see that everything is spread among all of the quadrants. Whereas when it was strong, weren't most of our points just in 2 quadrants? Isn't that a nice guide for them? When it's strong, it's mainly going to be in those 2 quadrants there. Put this one in, it'll be even stronger. So if they put in this point, the average height and the average arm span, and do their quadrants, it gives them a very good indication of whether it's strong or it's weak. So if the majority of their points are in this and this quadrant, we've got a strong correlation. So let's look at a negative one. So we can move all the dots over here. And let's see if we can make that correlation coefficient become negative. Where it looks like as my arm span is getting longer, my heights are getting smaller. We're nearly negative now, aren't we? Bring this little guy in. Now we're negative correlation. Isn't that lovely for the kids to see? Now, at this point, look, we're still just, we're too spread out, aren't we? We can see in general that we have a negative correlation going on here. It's similar to a negative slope, isn't it? A negative correlation, but it's still too spread out. So we'll bring some of our points back in. Okay, and now we're up into a strong negative correlation. Okay. And then I guess what we could also show them is, why are the boundaries -1 and 1? So let's try and make a perfect correlation of as close to -1 as we can. So if we try and line up all our dots, we should start getting really close to -1. So minus 0.95, 0.96. Bring these in. 0.98. Like, if the kids got a chance to just play around with this for a while, wouldn't they understand it very quickly? If I bring this guy and look. And we've got our -1 now for our total correlation of a negative correlation. So as my arm spans get bigger, my height gets smaller. Of course, we know that that's not true, isn't it? We'd look awful funny. Okay, so that's not true. We moved around the points there to suit ourselves. So what's good here, though, is we'll make it back sort of positive now. Now, that's all of your ordinary level leave inserts, isn't it? But what about the honours leave inserts? They have to take it a little step further, don't they? Well, for a start, they need to actually be able to calculate the correlation coefficient, don't they? So they can do that on their calculator, and we'll look at that today, and we'll make sure we can all do that in our calculator. And the other thing that they have to do is they have to do the line of best fit, isn't that it? Okay, so there's a correlation. Okay. Now, the line of best fit, if we click on this here, it will give us the line of best fit. Okay. And look what's really nice. What point does the line of best fit go through? Yeah, absolutely. The person with average arm span and average height. So not only is the mean of the x's and the mean of the y's a really nice point to help you navigate and understand what's going on, it's also a point that will always be on the line of best fit. So don't they have to draw the line of best fit by eye? They have no calculations that they can do. They just have to guesstimate where the line of best fit is. So if they've got that point, they're laughing, aren't they? Because they've got one solid point that it's definitely going to go through. Okay. And then the last thing that an honours leave insert student might be asked for is the equation of this line of best fit. Isn't that it? So again, what do you need for an equation? Well, you're going to need 2 points. And now look, you already have one perfect point on there. So they just need to pick another point and get their slope from that. And they'll get their the equation of the line of best fit. If we click on here, that gives us our equation. Okay. So the line of best fit, why would you bother doing a line of best fit? What's it for? Absolutely, it's for estimating. That's it. When we don't have a data point, it's for estimating. So let's just say, well, there seems to be a small little gap here, doesn't there? Just there. So that's a person with high arm span, we'd say 177. And if we wanted to know, well, I surveyed lots of people. I didn't exactly get someone with the height or arm span 177. What can I estimate their height is? That's when we use our line of best fit. We go up and go across and estimate their height. Isn't that it? That's important that the kids understand the purpose of the line of best fit. Okay. Do you think you'd use that? It's brilliant, isn't it? Really, really good for understanding the correlation. Okay. Right, so if we look at our teaching and learning plan, let's just see, let's say you do that in class, or you bring them to the computer room and let them do a few questions on it. Now we have a nice bit of homework for them, or a class activity. So just open up there on page 26, please. Okay. So, because the line of best fit is only for higher level leave inserts, can you see that this is just a higher level activity? Okay. And what we have is, the following table shows the weekly rainfall and the number of tourists visiting a certain beauty spot for 9 successive weeks. Okay, so there we've got our data and our 2 variables. We know the only way we can represent that is on a scatter plot. So the kids are asked to do a scatter plot of the data. The next question then is, find the mean rainfall and find the mean number of tourists. So can you see they're led into their getting their means, and then they have to plot the point x bar, y bar. So they're going to plot the point that has the average number of tourists and the average amount of rainfall. Okay. Draw lines parallel to the x and y axis through this point. So can you see how well this activity mirrors this? If you do this, then you have an opportunity to send them home with this for their homework. This splits the scatter plot into 4 quadrants. In which quadrants do you find the most points? Can you see what we're leading up to now? Yeah, if you're looking at where are the most points in what quadrants, that's going to help us with the correlation, isn't it? Okay, so then the next one is draw a line of best fit and draw an oval around the data. The line must go through x bar, y bar. So there you're told in the question, your line of best fit will go through x bar, y bar. The line of best fit also should go through the 2 quadrants that contain the most data points. So isn't that a lovely guide for them instead of just draw it by eye? Now they've got something to hold on to. I've got a point to go through, look at my quadrants. I'm fairly happy with that. It's a really good starting point. Okay, of course you could have just done the first page with an ordinary level Leaving Cert class, couldn't you? And just ask them to chat about the correlation at the end. Now, this is important. Number 7, on the 10th week, there was 4 centimetres of rainfall. Use your line of best fit to estimate. So that's the natural progression out of getting a child to do the line of best fit, is to ask them an estimation question, or else it's just really pointless. Okay? And then by picking appropriate points, find the slope of the line of best fit, and then on to find the equation of the line of best fit. And then it just ends up with a nice little context question. Okay, because of course you wouldn't do, a statistician wouldn't do this unless he had a reason for wanting to know the answer. So you have your nice little bit of context at the end on why you would have wanted to do this in the first place. Isn't that a lovely activity? Yeah, and that brings it all together really for any student. Okay. So this is one now that's a nice kind of, do they understand the correlation coefficient type of activity? Okay. So you can look up here, we've got graph A, graph B, graph C, and graph D. And we have options. One of these graphs has correlation minus 0.72. One graph is correlation of 1. One graph is correlation of minus 1, and one graph has 0, no correlation. So which one is which? So which one is minus 0.72? D. Very good. Okay, so this is D. Which one is correlation of 1? A. Perfect. So perfect correlation. Which one is correlation of minus 1? B. Perfect. And which one is no correlation? C. Now, would you forgive one of your students for thinking that B was potentially minus 0.72? Why would they maybe think that that one was minus 0.72? Yeah. Exactly, 45 degrees. They could get confused with slope. Very easy, couldn't they? Very easily go, oh, that looks like it has a slope of minus 0.72. That must be that one. So that's a really good question for teasing it and making sure nobody is confusing correlation with slope. Okay. So what we're going to do now is we're going to make sure we can do this correlation coefficient on the calculator. Right. So we'll go back to this nice question with the rainfall and the number of tourists. And what we'll do is we'll just look at the first 4. We won't do the whole thing. We'll just look at the first 4 groups of data. Now, again, same thing. We'll start with the Casio. So the first thing is put your calculator into stat mode. So do you remember how to do that? Go into mode. And isn't it going to be number 2 for statistics? So you're going into stats mode. Okay. Now, this time then it's going to ask you, what data are you putting in? And all morning we've been putting in 1 variable, haven't we? But now what are we putting in? 2. So this time we're going to choose the line option, number 2. Okay. And when you press number 2, well then what will happen? We'll be given 2 columns this time. So this morning we were only given 1 column. This time we're given 2 columns. And it's the same as this morning. You just put in your data, 4.5 equals, and it'll go into 4.5. And then go into 3 equals, and it'll pop up here. And basically where it will pop up is where the cursor is. Now you can move your cursor all around into the X column, into the Y column, just using your arrows. So using your arrow, move your cursor to where you want it to be, and when you put in your number equals, it'll pop into wherever your cursor is. So what I'd like you to do is, could you put in those 4 pairs of data? And when you're finished, what do you need to do when you're finished putting the data into a Casio? AC back out. That's it. So put in the first 4 and AC back out. Well then, what do we have to do now? We have to go back into the stats menu. So the stats menu then is above the 1, isn't that right? So we go in there. Now this time, do you remember this morning we were looking at variation when we were looking at standard deviation? So we went for the one VAR. This time, your line of best fit, your correlation coefficient, it's all about linear regression. Okay, linear regression. So that is why we are looking for REG. Okay, so linear regression is the fancy name for what we're doing. So we're looking for REG. Now, when you go in here, this is really nice. When you click into the regression, you'll get a table like this. Do you have that on your screen now? So we can see the correlation coefficient is always OR, isn't it? So 3 is the correlation coefficient. But look at the rest of them. Do you see this one, number 1A? That's actually the y-intercept of the line of best fit. So it's like a small little cheat, or they can check their answer when they do it to see if they were close. So there's their y-intercept of their line of best fit. Number 2, the B part, is the slope of the line of best fit. So they can make their line straight from that, can't they? And show obviously a bit of work in their exam paper. But it's a lovely way to check their answers. And you see number 4, number 5, the line of best fit, as I said, is all about its power to estimate. So these two here is number 4, the estimated value of x for a given y. So you could put in a y and see what would it estimate your x value to be through the line of best fit. Or this one here, 5, estimate the value of y for a given value of x using the line of best fit. So it'll do that for you as well. So it's honours leaving cert students, it's worth getting to know that little menu of data there. Okay. Is everybody happy so far? So we'll go ahead and get our correlation coefficient. So go into linear regression, choose OR equals, and it's minus 0.77. So how would we describe that in terms of positive, negative, weak, strong, minus 0.77. Negative, strong, perfect. So it's negative and it's over 0.6, so we'll say it's negative, strong. Is everyone happy with that? Okay, lovely. So I'll just do the same now for the sharp calculator. Okay. Right. We'll use the exact same example. Now, do you remember what you have to do? You have to get any kids with this to clear their memory first. Okay? So we go into clear and we choose number 2 and reset it. And then we have to press 0 and it will clear it for us. Okay. Now we have to go into stats mode. So choose number 1 for stats mode. And then, like this morning, we chose 0 for single digit. Now we're going to have to choose 1 for a line model for 2 variables. So we choose number 1. Okay. And now it's waiting for us to put in our data. So do you remember this morning what we did was, let's say I wanted to put in 5 and it was just 1 variable. Don't I go 5, press my data button and it goes in. So this time then I'm going to put everything in as a couple. Okay, do you see that one there? It's just over the data button, but it's an actual couple button. So we will put everything in as a couple. So 4.5, press that button, it puts in the little apostrophe for the couple, and then press data, and you've got 1 in your data set. Okay? So do you see how that's working? And again, like this morning, it's counting the number of couples in your data set. So you'll put in 4.5, press your couple button, put in 5, and then nominate it as data, and it'll go in here and be accounted for here. Okay. With your sharp, what's the thing? They do not need to AC back out. So all they have to do is go directly from here to wherever their correlation is here. So we have to look for correlation. And what you'll see is it's over the division sign. Okay? It's over the division sign. We have the little or here. It's in green, so we'll have to go alpha division sign. And that will get us our correlation. Okay. And we've our minus 0.77. Also, you will find here that you can also get your A and your B for your line of best fit as well. Okay, the A and the B are here as second functions also. Okay, so just to mention to you that, as I said earlier, all of this is online, these PowerPoint presentations, but you see this little one for the sharp calculator, it's free online. The little emulator, you know, where you can just put it up on your data projector and you can kind of use your cursor to push the buttons. So it's free, you can just download it, just go sharp emulator and you can download it for free. You can't get the Casio one for free though, I think you just have to purchase it. Okay. Right. So that was a lot of statistics today, but we've basically covered nearly all of the course, haven't we? Doesn't it give you a little bit of hope when you see going through it so quick compared to the 70, 80 pages that are in the book? Because it just looks like, oh my God, we'll be here for half the year doing these statistics. So the census at school, it just makes it nice and choppy, keep it moving and keep the kids talking. Isn't that the big thing? Because when you look at the questions that are coming up, it's a lot about descriptions, isn't it? Descriptions and interpretations, and they need to be comfortable with talking about a distribution. Okay, so what we're going to move on to now is a little bit of algebra. So it'd be nice to do something different. Now, when it comes to algebra, have you ever heard the kids say, Miss, What are we doing this for? Who's ever going to use this? You know, what's the point? So I guess we kind of looked at getting together a kind of clear philosophy about what our standard answer to that would be. Like, why are we making the kids do algebra? And really, when you look at it, students really ideally would see algebra as the language used to describe patterns and relationships for the ultimate goal of problem solving. That's really what it's about. It's about problem solving, and we know up into engineering, architecture, computer science. But algebra is the language that allows us to talk about the patterns that we see that helps us to solve the problems. And that's the power of algebra. So that's our philosophy. And I guess the current school of thought would be that for really effective learning when it comes to algebra, that algebraic thinking is nurtured in parallel with arithmetic understanding. So what does that mean? What that means is your arithmetic understanding basically means that they would first of all have a really solid understanding of their number theory. Secondly, that there would be an explicit association between algebra and number. Because when they get to algebra, what you want them to realize is algebra is the exact same thing as number theory. It's the exact same rules. If you know the rules of number theory, you know the rules of algebra. That they're not two separate things. So that we would make sure to join them up at every opportunity. Say, well, put some numbers in. It's the same rule as you would have for numbers. So that's the arithmetic understanding that you're talking about. But on top of that then is the algebraic thinking. And what that really is talking about patterns and relationships. Because in the end of the day, that's what algebra is going to be used to describe. So patterns and relationships, very important. And through doing patterns and relationships, we discover a really good understanding of the variable. Okay. And obviously keeping in mind the whole time the problem solving aspect. Okay. So when it comes down to it, if we were to think of how are we going to teach algebra to first years, it's going to be number theory, then it's going to be patterns. So what we'd ideally do is all of our patterns up to y equals mx plus c first. Now that's all workshop 4, do you remember that? So that's ideally what you want to do first before you touch algebra skills or anything like that. And then after that, after you've introduced the variable through patterns, then we can look at a few skills. And when we talk about algebra, then we would constantly refer them back to their number theory. And then, I guess, help them to alleviate whatever misconceptions they have, because we know they have a few when it comes to algebra. Okay. So why is it important to do patterns before algebra? You know, what's wrong? Why would you do that? Well, it's really because of the traditional way we teach algebra. And I know we're all guilty of this, me included, okay? That the first years, it's coming up to Christmas, better get my algebra on the road, isn't that it? With your first years. And we start teaching them how to add variables through something tangible, buses, or here we have 4 apples and 3 bananas. Now, the difficulty here is, to the student, what is A? Well, it's an apple, isn't it? It's an apple. So why would they ever associate the rules of algebra with the rules of numbers? Do you know what I mean? That association hasn't been made. So this is really why we go about doing it a different way. And it's called the relationships-based approach to algebra. Do you remember hearing all about it in workshop 4? Okay. It's basically how algebra is taught in most of the leading countries around the world, is the relationships-based approach to algebra. So we're starting to follow suit with everybody there. So workshop 4, I know you hear me talking about it and you're like, yeah, I remember a little bit about that, not much, because of course I give 20, 30 of them and you only hear it once. Isn't that it? So we'll just have a little recap on it. So do you remember we did the Moneybox problem and the sunflowers problem? And we got them to make a table, and then we got them to do a graph, and then we got them to do a formula. Okay, so how it worked was like this. Just to give you a quick reminder. Is this working okay? So the Moneybox problem was, okay, we've this guy and he saves €2 every day. Okay, but he got the money box as a present. And when he got the money box as a present, there was €3 in it as part of the present. So he's like, great, I'm starting with €3 and I'm going to save €2 every day. So we got the kids to first of all make a table. So it was the days and the amount of money I have in my money box. Isn't that it? And every day they save €2. But a very important skill that we teach the first years is they need to start on what number with days? Yeah, you have it. 0. Exactly. So day 0, or when time begins, is that moment when I was handed the money box. And how much was in it? €3. So at initial time, at time 0, I had €3 in my money box. And then every day after that, I saved €2. So on day 2, I now had €7. Day 3, I had €9. And what we got the kids to look at then was the change that was happening here in this table. So when I look at the change in my amounts, I'm adding €2 every day. And we got them to see that as a constant rate of change. Do you remember this? So now this is a constant rate of change that's happening in this money box. And this was lovely because we got to tell them that this number is constant, but my days are always changing. Okay? So the days, this is what we would call a variable. In a variable, the quantity changes. Because we want the kids to see a variable as a changing quantity, not as an apple. Isn't that it? That's where we're coming from. And the amount that's in the money box, doesn't that change every day? So that's a variable, the amount. And then my constant is the change. And then we got them to put it on a graph. And when they graphed it, they saw, okay, my graph is a straight line. So when they graphed it, they were like, oh right, a constant rate of change gives me a straight line. And then we helped them into discovering that where does it start on the y-axis? At 3, with your start amount. So your start amount will always be on the y-axis. And then your rate of change, we taught them that, well actually, if you never saw this, I bet you could get the rate of change from just the graph. And how did they do that? Rise over run, exactly. So then we taught them to do their rise over their run. And using their rise over their run, they will see that this slope is 2. And that's how they can see the rate of change on their graph. Okay. And then finally what we got them to do was to make it into a formula. Wasn't that it? That's the final step. So the final step was, if I had any room, I'll get a new wee marker for this one. So the final step then was the formula. So what happens is that the amount I have in my money box equals the 3 that I started with plus 2 multiplied by the number of days. And isn't this just y equals mx plus c? And that's where you bring them to. And through all of that, like there's a huge amount of work in that and a huge amount of discovery. It's all your Workshop 4. It's all online under Project Maths under Workshop 4. But through bringing them up to this really good understanding of a line, they now know that A is a variable, D is a variable, 3 is a constant, and 2 is a constant. Okay. And then when I go into algebra, all I'm doing is teaching them how to add these things together. But they already have a lovely understanding of what it is. Okay. So it's all about the variable. So just going to have a little look here. If you look in your workbook on page 21, if we look there on page 21, okay. I'm just going to bring you through this really quickly because the functions-based approach or the relations-based approach to algebra can be quite difficult to navigate around a book. Because depending on what textbook you use, they might have put patterns after algebra, before algebra, in the middle of algebra. You know, there's a certain amount of bedding in, isn't there, in this whole process. So this is a little roadmap for you to follow for teaching your algebra. Okay? So just like we said there, basically there's your 1, 2, 3. So number 1 will be your number theory. And we're going to do some work on this. Array models, they're visuals for number theory. They're really good for the kids. We're going to do a bit of that in a minute. Once we have our solid number theory, we get into our patterns, which is really just the T&L on patterns, isn't it? You've got your T&L, just get it out, have a look at that. And this is all lots of work with unifix cubes. Getting them to a kind of before they use symbols. Okay. And then there's a very deliberate focus on a relationship between two variables. This is where our Moneybox problem comes in, and this is where they start to understand about a variable. Okay, and they start to use their symbols to generalize a pattern, and they start to see it as a way of problem solving. So you could give them a few problems about their Moneybox and things like that, and they see it as a tool there. Okay. So then the reality is that we're trying to coach them on what a variable is. Now a variable can be looked at in 4 different ways. We use variables in their little formulae for their areas and volumes and things. We use variables for their laws, their identities, like the commutative law, x plus y equals y plus x. We use variables for a relationship like the Moneybox problem, y equals 2x plus 3. And then the final way we use a variable is an unknown. You know 2x equals 6. But doesn't this tend to be as far as they get sometimes? They just see it as an unknown, not as a change in quantity. So this is the power of doing the patterns, is that they see it as a change in quantity first. And then we can lock it down into an unknown by throwing them up a little problem or something. Okay. So then we could get into our algebra skills. Now algebra then, that's realistically the end of first year, isn't it? Like you'd never get to it any sooner than that with the amount you have to do in first year, especially around patterns. So that's around the end of first year. And what we'll do is very much, don't forget, their number theory would have been at the beginning of first year, so I've a little arrow in here, remember to connect it back with all that number theory. And then alleviate the misconceptions. Again, we're going to talk a lot about that today. Right. So we're going to go on and do a little bit on equations then, and all the things, and word problems, all the things that come out of algebra then. And this is the big thing. The reason this is here is because it's out of the syllabus, okay? The relationships-based approach to learning algebra should culminate in students having a deep understanding of algebra, which allows easy movement between story, table, graph, an equation. And that's, if you look at the papers, that's how they've changed. It's all story, table, graph, formula, isn't it? So I know patterns can be like, oh my God, it's going to take me 3 weeks to get through that. Actually, my bunch, it's going to be 4 weeks to get through that. But the amount of payback that you will get for embracing the patterns will be massive. So I just kind of, if you can give it a go. Right, so we come out of that then, and we'll extend it on into a little bit of factorizing. So you have that there for yourself, just in case you're wondering what comes next. Right. So, as I said to you, now that they understand the variable, we can then just extend the Moneybox problem even to introduce an unknown. Just give them a question like, well, John's savings, like over here, his amount is €3 plus 2 times the days. That's his savings. Well then, how long is it going to take him to save €42 for a video game? Now all of a sudden my formula is locked into a specific unknown. And that's a nice entry into your equations. Now, when it comes to equations, guys, equality is a really interesting concept. Right. Because if we look at it, you know your little first years come into you, and you think they know sometimes a little bit more than they do, don't we? They don't know a whole lot when they're coming into us, right? And because they've been doing little things in school like 2 plus 3 equals 5. Okay, now, in primary school, what does that equal sign mean? Is. Yeah, that is 5. Get the answer. Teacher wants the answer. That's what that means. Whereas actually in secondary school, what we want them to understand about that is the left is equal to the right. That it's the idea of equality. And sometimes we're halfway through equations, and you know what? They mightn't even know what equality means. Like they're coming from a different place with regard to that instruction. So you'll see that today I'm going to talk a lot about different worksheets, and they're all online. Again, they're all under the Workshop 5 tab. So there's a worksheet there just to get them to consolidate their idea of equality. It's very, very easy. And after that then, we can get them into looking at equations. Now, have you ever heard of the stabilizers method for equations? You have, yeah? It's really nice. So let's just say we had 2x plus 5 equals 17. Okay. The stabilizers method, and this is there's a whole T&L on equations, is where the student puts little stabilizers on, and we know what they do to one side, they have to do to the other. So the first thing they need to do is subtract 5 from both sides. So they subtract 5 from both sides, and they're left with 2x equals 12. And now we know that we have to divide both sides by 2. So they have to divide both sides by 2. So they have x equals 6. Okay, isn't that a nice kind of teaching methodology? Because they find this idea, the 2x plus 5 equals 17. When you teach it to them, oh, they're brilliant. It's 2x equals 17 minus 5. And then when they come back in second year, it all goes awry, doesn't it? It's like, oh, I bring the 5, something over here, isn't it? And it's a plus 5 over here, and they forget to change the signs. And it's because there's just a little bit of lack of understanding in it that they can't remember it. So that's a nice way to look at their equations. So they keep on their stabilizers. When they get really good, what do? Take off their stabilizers. When they come back in second year and they haven't a clue again, what do they have to do? Put back on their stabilizers. That's it. Okay. So just talking about some of the misconceptions. What kind of misconceptions do your first years, second years, third years have in algebra? Fifth years, sixth years? What sort of misconceptions? When you're correcting tests, you're like, there we go again, there we go again. What are the things you see wrong all the time in algebra? Signs are, yeah, their signs are not good. Okay, yeah?
Adding 2 unknowns. Yeah. Add 2 unknowns.
Yes, okay, so x plus y equals like xy or something. Yeah, just stick them together. Yep.
Things in brackets and that, you know, multiplying in by brackets, you know bracketing.
Oh, bracketing, so like a plus b on c plus d type thing.
Yeah, or 2 into it. Yeah.
Or even just 2 into it.
Yeah. 2a equals b.
Yeah, exactly. 2a plus b. Yeah. What other things do you see?
3a plus 7 is 10a.
Yep. 3a plus 7 is 10a. What about their x squareds? X squared minus x equals x. It's a minefield, isn't it? Just the amount of variations on a theme that they have going on with algebra. One of my favourite ones as well is, well, when I say favourite, I mean I absolutely hate it. Okay, is a plus b all to b squared equals? Yeah. Yes, the 5th years are particularly good at that one. Okay, so what we're going to do is we're going to have a chat about how we might alleviate some of these little issues. Okay. Now, the first thing is, I guess, like we said, it's, for a start, they're not thinking of it in terms of numbers. So if you do want to give something solid for them, something tangible, so they understand they're adding them, maybe a nice thing to do would be to, from the outset, a equals 5, b equals 2, and c equals 8, so that they know from the outset it's a number. Get them to add them all up, and straight away get them to evaluate it. Do you know what I mean? Straight away get them to put in the numbers and evaluate it. Because at present, isn't it 2 pages of adding and then 2 pages of putting in numbers? You know, they're separate, aren't they? They're like separate types of questions. Another thing, because now they know it's a change in quantity, we could say, here is a nice expression, which they don't understand as well. Sure, they don't. What's the difference between an expression and an equation? Huh? Yeah, it's hard, isn't it? Like, it's a lot for a first year to take on. So this is a nice expression, but these can all be changing numbers. So maybe get them all to say, right, let's do some more. What do you want A to be? What do you want B to be? What do you want C to be? Let's reevaluate it, and kind of training them up like that. Now, for the different types of terms, this is the problem, isn't it? Adding different types of terms, thinking you're allowed to subtract x from x squared. We have some big problems there. As well, do you ever see them getting x squared and 2x confused? Like as if they're the same thing? Or even not understanding what 3x squared is. Is it 9x squared? Is it 3x squared? So a nice thing there is, have you ever heard of algebra tiles? These are really lovely. I have them here for you. They're basically, what they do is, they train the students into, this is x, and this is x squared, okay? You're training their mind's eye into a squared is a square, okay? And an x is a length. So that, why would you take away a length from a square? You're trying to train up their mind's eye to give them something tangible to work with. Now, if you had these, that's great. You don't need them. They can draw these. They can easily draw these and get a visual without ever having to have algebra tiles in the classroom. So there's some algebra tiles there. There's your x. So x, and it's 1 unit high. So that's x. So now this is 2x, but that's x squared. Isn't that nice to give them a visual? Why are they not the same? That's 2x, that's x squared, it's a square. What's 3x squared? Well, it's 3 squares, isn't it? That's what you want them thinking. Oh, that's 3 squares. So a nice thing to even start off with would be, give that to them and say, will you draw it for me? Draw that for me. So they don't need any of this fancy stuff. Draw it for me. I have 2 squareds, I have 3 lengths, and I have 5 units. And then you could give them 10 of those to do for homework, couldn't you? Until it got into their head that squares and x's are different. Okay. So another worksheet then. Have we look at page 22 then? So this is a little activity that you could do with them in class. Again, this activity is under workshop 5. So I guess we would need to present to them the idea that because x is just a number, isn't it easier to start with a number? So how could we represent 3? We could represent it as a little area where it's, my length is 3 and my height is 1. So this is 3. Or another way of looking at it could be, how would I represent 4? Well, it's going to have to be longer than 3. There's 4, its height 1, but maybe it's 4 squares across. So that represents 4. So then when it comes to x, well, we don't know what length x is. Sure we don't. It could be any length. So any length, it doesn't matter. And this would be x and 1 high. So that represents my x. Now in that activity, do you see you were told x is not equal to y? So it doesn't matter what we make x, as long as we make y just a different length. Absolutely, doesn't matter at all what we make y. Okay, so will you go ahead and do that for me then, that activity there in your wee pairs? Do you need a travel form? What do you make of that? The idea of them drawing and getting a tangible idea of their algebra. Isn't it lovely? And it is definitely, they could do it into their copy. You could write it on the board. You don't need anything fancy for it. So we have here then, we have our x and our y. So we have 2x. Then you had to draw x squared. Then you had to draw 4x squared. Then 2 on x plus y. So we add x plus y together and make 2 of them. Or another way of looking at it is 2 x's and 2 y's. Now there could be a whole class in that really, couldn't there? The discussion around that. Especially this one. Isn't it lovely that they get to see that 2 on x plus y is the exact same thing as 2x plus 2y? And again, what you're looking for is a visual, because remember you said they forget to multiply in the 2 to the y. They forget to multiply the 2 in. Okay. So what about this one? Well, we talked about this one and we talked about their problem in general with multiplying out brackets. So let's have a look at this. I think you're going to like this now. Okay, so if I look here, okay, so if you look here, we have got 14 multiplied by 12. And this is the level that the kids are coming into us with, isn't it? That they will have learnt their long multiplication, and they get 168. Now what we can show them is another way of looking at this. What if I looked at it with the units instead? So now 14 is 10 units and 4 units to make my 14, multiplied by my 12 is 10 units and 2 units, and multiply the two of them together like you would with area. If I count all my units, I'll have 168 units. Okay. Now we could take that a step further. Let's leave the units because we know it works on a premise of area anyway, doesn't it? So let's look at it from an area point of view. The kids could just do a little rough diagram, no rulers, just a rough diagram, and go, do you know what, 14 times 12 is the same as 10 and a 4 times 10 and a 2. 10 tens, the area here is 100. 4 by 10, the area here is 40. 10 by 2, the area here is 20. And 4 by 2, the area here is 8. If I add those together, what do I get? 168. Okay. Now, would you have any idea why we would use a model like this? It's called the array model or the area model. Why would we use a model like this to break down this multiplication over here? Absolutely, getting them into the habit of using the second term. Because what we're doing is we're just looking at the distributive law, but we're looking at it in number theory instead. We're consolidating the distributive law there so that exactly it's all about the second term. When they come to do this, remember you were worried they don't multiply in all their terms, x plus 2 by x plus 4. Go over to the side, do my little rough model. X plus 4 times x plus 2, x by x, well they know it's x squared from their area tiles. 4 times x is 4x, x by 2 is 2x, and 4 by 2 is 8. And this is, if they do enough of these, they will come to understand that there should always be 4 terms in my answer. This is what you want. You want their level of expectation to be there for what the answer should look like. So 4 terms in my answer from the 4 quadrants, and then I simplify. Now, if they did enough of those, wouldn't that really help alleviate some of those misconceptions? And then when you're happy that they've done enough of those, of course, then we can teach them the shortcut for the distributive law. Whatever your shortcut is. Some people use smiley faces, etc. Everybody has their own way of doing the distributive law. But this is how they do it in school. But this is so abstract, isn't it? Compared to this. This is a no-brainer. So easy. Okay. So what you'll see is in your handbook and online under Workshop 5, there's worksheets there if you want to try them out with the kids in class. There's ones that are just numbers and then they have to do their own area models. And then you can move them on to algebra. And you can bring them right up to, look, the really hard ones, x plus y times x plus y, and have the chats with them about that. If you teach any resource classes or any particularly weaker kids, there's one online there under Workshop 5 that brings them to the distributive law, but just a little more gently, okay? Just working their way into it. And there's some teacher notes to go with it. So we're hoping that when they come to something like this squared, what should that look like? What should something squared look like? A square. Okay, so that's a good start. I know that that should look like a square. And what is it? It's x plus 3. So it's x plus 3 multiplied by x plus 3. And now I can see, if I only have 2 terms, I'm way off, isn't that it? So x squared, 3x, and 9. And these are the 2 that they miss, isn't it? Usually. Okay. If you've got a junior cert class, 3rd years, you know sometimes they struggle with these. Again, if they're not going into the second one, they're definitely forgetting about the 3rd, isn't that it? But again, something like this, you can adapt the area model to suit yourself. So you could just say to them, sure, use your area model. If you're comfortable with it, go for it. Makes it very easy to do. Because you'd see that in an Honours Junior Cert exam, wouldn't you? Makes it so easy to do, and it helps them make sure they don't forget any of the components of the sum. So another thing that they have a small bit of difficulty with, do you ever notice the order of operations? BOM-DAS, when to square things out, all of that. Very, very difficult. So again, there's another worksheet there for you, all on the BOM-DAS rule. But what I'm going to ask you to do is, it's on page 24. And there's a little bit of problem solving in this as well. We're not just spoon feeding them the BOM-DAS rule, we're getting them thinking. Would you do 4 part 2 for me there in your groups? 4 part 2, page 24. You're matching these 4 statements with one of the 4 diagrams. C, very good. So C, 3 squared and 4 squared, perfect. Then we had to look at 3 times 4 squared. Which one was that? D, perfect. 3 times 4 squared, so 3 squares, perfect. Now the next one was 3 multiplied by 4, all to be squared. Now it's all to be squared, so what do we know we're looking for? A square, a big square. And it's 3 times 4, so which one was it? B, exactly. So our sides were 12. 3 times 4 squared. And then the last one, 3 plus 4, all to be squared. What are we looking for? A big square. Okay, and which one was that then? Perfect, A. Our sides were 3 plus 4 times 3 plus 4. That's it. Okay, if you think your kids could cope with that, you could give that to a 5th year class, couldn't you? And get them thinking about it. That's it for anybody. If you want to extend your problem solving, I won't get you to do it here, but you can get them then to do the same thing, but in terms of variables. And that really put the cat among the pigeons. Okay. So again, all of those are online. So what we're going to do now is, this will take you about, I'd say about 10 minutes, no more, but you're going to enjoy this. It's a matching graph activity that's going to bring all of this together, okay? So clear yourself a little bit of space.
2, 6 is 10 over 2, sorry, 8 over 2 multiplied by 4, that's it, yeah.
So if n is 3, right, 3 twos are 6 plus 6 is 12, and it's 4 twos are 8 plus 6 is 14.
So as I was saying, as I was going around, guys, that's under Workshop 5 as well. So if you want to download that and do it in your classroom, it's under Workshop 5. It's called the Matching Graph Activity. And there's another page that goes in with it if you want to layer on top, where you can get them to cut out graphs and layer on the graph that matches what you have there as well. Okay? So we just have one more little thing to do, and then we'll finish off the day. And I think you're going to appreciate this, because it's just taken that little step further into helping them with their factorizing. Don't they have a few wee issues with the factorizing? So this will help them with the factorizing. So you see here we have grouping. And they can find the grouping tough going, can't they? But now look at the grouping. All it is our 4 terms from our 4 quadrants of our model. So if they put those in, all they have to do is work backwards. So they have to look and see, well, what could be here? If this is AB and this is BC, what would that have to be? B. Okay. They kind of just go process of elimination. They don't learn any rules for it. They just try and mooch it out for themselves. So if that's B, then what's going to have to be here? A. Perfect. So if that's A, this is DA. So what's that going to be? D. And if that's D, this is minus DC. That has to be minus C. Perfect. Do you see the way there's no rules? They just mooch it out for themselves instead of having to learn the rule. Wouldn't that be lovely for students that are finding that difficult? Okay, again, so the factors then will be A minus C and B plus D. And again, there's a worksheet all on that if you want to go through it. It's under workshop 5 as well. Okay, and there's some in your workbook there as well on page 27. Now you could reuse the grouping method for any student that's struggling with quadratics. Okay, so if you have someone that's just not getting it. Have you heard of the guide number method of doing a quadratic? This is really nice. Instead of, there are some students that find this idea, last one's a plus means it's this, last one's a minus means something else. What's the first one again? And it's all of these sign rules, and some of them just find it difficult. So the guide number basically is this last number. And what they're told is nothing but what can make plus 6. Okay? So 6 by 1 can make plus 6. So can minus 6 by minus 1. 3 by 2 or minus 3 by minus 2. And they're trying to make the minus 5 in the middle. So we would go with minus 3 minus 2, wouldn't we? And we separate it out like that, and now aren't we just back to our grouping? Now it's just back to the simple grouping, and they just tease it out from there. Isn't that a nice method for someone to find, because they already understand the rules of signs. They mightn't just get it when it applies to the extra rules on top of factorizing. Okay, and they just read this straight off here. Now again, you know the way some of your kids, these can be really difficult, can't they? They've got the 2 going on, the 21 going on. The last one's a minus. That's just a minefield, isn't it? Okay, so the guide number in this situation is you multiply the coefficient of the x squared by this number. So my guide number there is minus 42. Now first of all, what makes a minus? Well, it has to be a plus and a minus, doesn't it? Can't be anything else. And then my factors of 42. So I need to pick one of these. It's a plus and a minus. That'll make a minus 11. So what will it be? Yeah, a minus 14 and a 3. Separate it out. Doesn't matter which way you put it. It'll work out no matter what anyway. And off they go with their grouping again. It's just another way. What do you reckon? It's nice though. If you were going to teach them the array model, it would help them a little bit. Loads more activities on that. And then we'll just finish off the day with this. This is lovely. The difference of 2 squares. Okay? X squared minus y squared. Well, what is it? What's x squared? A square. Take away a square. It's just a square, take away, presumably a smaller square. Okay, so x squared take away y squared. So what am I going to be left with? Well, I'm going to be left with all of this blue part, aren't I? That's my answer, all that blue. So if I divide it into 2 areas, wouldn't you do that when you're talking about area? Divide it into 2 areas. So the length here would be, if that's y, if I've cut out y out of x, then this bit that's left is x minus y. That's the width of the y box, y squared, y. That's my area A. And then that's the length x. And up there, that was x, and I cut out the y, so it's x minus y. And that's my area B. So the area of A will be y times x minus y. The area of B is x times x minus y. Add the 2 areas together, and it's x minus y on x plus y. Isn't that just lovely? Now, if you have, again, there's work on that under Workshop 5. If you have any honours leave inserts, I'll leave you with a question now that I would give them. How to keep them going for a little while. It's totally possible. Can you draw a model for the difference of two cubes? Same thing. They'll be able to work out their formulae from that, no problem.